Hi, how you doing? How's this awesome Friday treating all of you? Hey, can you just show me the comments? I can still see the full screen here. What's up? Look at this cool thumbnail in front of you. Graph scaring some of you maybe. We'll talk about this. So we are going to look at, hey, Lakshya. Radhe, Hare Krishna. What's up? Tanesh, Sona, Vane, Mayuk. What's up? Good evening. Hey. So we're going to look at leaching. Hey Vaishnavi. Roasting and Ellingham diagrams. We're going to get right into it. ये वाला सेशन थोड़ा theory heavy होने वाला है and then we'll get into something very interesting. Okay. क्या आप लोग इसको already पढ़ चुके हैं? What is an Ellingham diagram and all of that? Have you already studied this? If yes, then great. If no, don't worry. इतना पक्का होगा you'll never forget it in your life. पहला वाला, the first half of the session is going to be pretty chill. We're going to talk about leaching, roasting, all that extension of the last time session. After a long time, Mayuk, what's up? I know. Hey. Good evening, Lakshya. Awesome. So let's get started right away. Yeah. So we looked at different ways of concentrating ores. I can move to the other side now. Yeah. Last time we looked at hydraulic physical ways, right? Hydraulic washing, magnetic separation, और तीसरा क्या था याद नहीं आ रहा है. Hydraulic washing, magnetic separation. Can anyone help me with the third one? Yeah. I'm not asking you guys. Chill. I'm asking the guys on this chat. Yeah, I know, Mayuk. It's okay. It's one of those chapters where you just make a little bit of notes and you'll be good. Froth flotation, Mayuk, perfect, absolutely. Hey Asya, good evening. Hello. Yeah, absolutely. Froth flotation. And उसके बाद I said कि chemical methods हम लोग करेंगे इस session में. Yeah, which is leaching specifically. After that we're going to look at extraction of crude metal from concentrated ore. ये बस एक लाइन है और दूसरी लाइन लिखी है thermodynamic principle metallurgy. But थोड़ा सा समझने वाली चीज़ है. इस पूरे चैप्टर में ये सबसे ज़रूरी है in my opinion. From the point of view of कि यार थोड़ा सोचना पड़ेगा, थोड़ा समझना पड़ेगा, right? खैर, anyway, yeah, let's get started. Tanu, yes, absolutely, froth flotation. Hey, Deepanvita, hello. Hey. So, let's get started right away. We're going to talk about concentration of ore using chemical methods. What chemical methods? Leaching specifically, okay? Leaching, अगर आप chemical engineering नहीं, most you're going to be doctors, right? Anyway, I'm going to go into my JE mode. But basically in chemical engineering, we use this method a lot to clean some sort of materials, right? When there's a lot of chemicals and you don't know how to get rid of them, you put in a solvent that dissolves some things and doesn't dissolve some things. That's exactly what we're going to do. So the goal is using a suitable solvent. Now usually solvent क्या करता है? बस dissolve करता है. But यहाँ पे एक reaction होगा. Reaction will happen. By the way, guys, if you feel that I'm talking, मतलब हिंदी ज़्यादा हो रहा है तो बोल दो. I'll switch back to English. Or if you think English ज़्यादा हो रहा है, you want me to go switch back to Hindi, just let me know in the comments. I know a lot of people watch this video after the class goes live. I hope it's clear, yeah, whatever I'm saying. Anyway, I think YouTube आजकल captions भी डालता है. Cool. All right. So, what is leaching? Couple of examples. The most simple one is alumina. Okay, aluminium की leaching, and the little complicated one is silver and gold. But दोनों के ideas are the same. The background, the main concrete idea is the same, which is कि we are going to use something called a cyanide ion. Very interesting thing, yeah, and it will remove all impurities like SiO2, TiO2 and Fe oxides in bauxite, which is the most common ore of aluminium, right? Oh, let me write that. Okay, cool. Principal ore, sure. It's already written on top of that. No, good in Hindi? Okay, cool. All right. Perfect, great. So, what do we do here? The first step is, okay, we put something called NaOH. NaCN दूसरे वाले का था, ठीक है? Aluminium and zinc are very special metals. They react with both acids and bases. They are known as amphoteric ones. But their reactions are very different with acids and with bases. With bases, they form complex compounds. ये हम लोग coordination chemistry में detail में पढ़ेंगे. But for now, एक दो reaction आप खुद जाके पढ़ सकते हैं, ठीक है? And this is what I'm talking about. So you have this powdered ore and you put NaOH in it. Now this NaOH dissolves alumina. And it leaves behind some impurities. That's the first step. And उसके conditions यहाँ दिए थे, एक बार देख लीजिए. Okay, what is 473 Kelvin? 200 degrees Celsius. And what is this? 200 से 250 degrees Celsius. Right? Is that right? हाँ. And very high pressure, 35-36 bar. Khair, these are the impurities that get left behind. And this guy is dissolved. Now, I have solved one issue, but I've created another one. ठीक है, I have removed some impurities, but now I have a compound of sodium and aluminum hydroxide, OH4, जो भी लिखा है यहाँ पे, this is a complex. So I need to get back aluminium, right? Specifically, I need to get aluminium oxide. You be like, अरे रुको, we started with aluminum oxide Al2O3, फिर भी आप बोल रहे हो वापस we'll get to Al2O3. देखिए, we are trying to remove some impurities, okay, that were present, like these chaps right here. That's the most important focus right now. Remember, this is concentration of ore. उसके बाद हम लोग देखेंगे how to work with this chap right here. A quick hint, it has to do with electricity. ठीक है? So basically ये बन जाता है ये. Let's look at an interesting animation to make this work. Oh, hold on. चला गया. एक बार फिर से करते हैं. One more time. Here you go. So, in this first step, which is this digestion vessel right next to me, right? Oops, इस तरफ. That's what we're going to focus on. Sure, there's carbonation tank and furnace. उसके बाद we'll talk about that. In this first one right here, देखिए क्या होता है. ये Al2O3 dry powder है यहाँ पे, ठीक है? Yeah, that's impure. मतलब कि उसमें TiO2 वो सब चीजें, SnO2 वो सब चीजें हैं. Okay? तो Al2O3 solid react करता है NaOH के साथ and पानी at this 200 to 250 degrees Celsius and 35 to 36 atmosphere bar and it gives you this. ठीक है? बाकी everything else का क्या होता है? We'll see very quickly. That's what's up next. ठीक है? Now ये जो था मैंने बोला ना कि हमने एक चीज सॉल्व की दूसरी चीज we've created another issue. What is the second thing? We wish to get pure alumina. Absolutely, Mayu. Hey Abhinandan, hi. Good evening, Sonali. What's up? Okay. So how do we solve that thing that we just created, the issue that we just created? I'm saying here कि aluminate is neutralized. मतलब कि aluminate must be a base. क्योंकि you know that CO2 is acidic. How do I know this? मैं इसको जैसे ही पानी में डालता हूँ, this becomes carbonic acid, right? That's how you know that something is acidic or basic. Khair, anyway, and what you get is this precipitate right over here and NaHCO3 जो dissolve हो जाता है. Let's see how that happens with this nice animation once again. This is the carbonation tank. The next step after the digestion vessel, this goes in here. Yeah, NaOH hold NaOH 4 times that comes in from the top. Carbon dioxide gas इधर side से आता है and then ये चल नहीं रहा है, रुको. Let me play that one more time. Okay, NaOH ऊपर से आते हैं, NaAlOH4 ऊपर से आता है, CO2 gas यहाँ से आती है and then together there's a neutralization reaction and what's left is Al2O3.H2O, which is good, but .H2O, it's still hydrated. Okay, I need to get rid of that. So this is the solid I get, but I need to get rid of that. Next step ये है कि हम लोग के पास अभी भी what is remaining is this sodium silicate in the solution. तो ये hydrated alumina है, इसको मैं अगर filter करूँ, dry करूँ, heat करूँ, then what I get is dry Al2O3 for my next step. Hey Mansab, good evening. What's up? Hey Maurya, good evening. Hello. Yes. Any doubt so far? थोड़ी सी कहानी चल रही है. Nothing fancy. 3 steps हुए अभी तक. Whoops. Let me silence that. Sorry about that. 3 step हुए. पहला step क्या था? पहले मैंने इसमें NaOH डाला. NaOH डालने से NaAlOH4 बना, which is dissolves and जो impurities थी वो निकल गई. फिर ये मैंने इसको neutralize किया with CO2 in the carbonation tank. And now what I have is hydrated Al2O3. Then I go and filter it and dry it and heat it in the furnace, right? Furnace मतलब गर्मी. देखिए यहाँ पे यही हो रहा है. This right here. Okay? Nice, cool, tiny animations. Just quick GIFs that make this work. This one's a video, but yeah. That's it. It's as simple as that. Okay. Great. Now this is done at a very high temperature, as you can see. Hold on. Pause. 1470 Kelvin. Something for you to remember. ठीक है? NCERT पढ़िए. That's your best bet. All right. And from here you get Al2O3, which goes to electrolysis, which we'll cover in the next session. अभी आज कौन सा है? अभी दूसरा सेशन है ना? चौथे सेशन में हम लोग वो करेंगे. Okay. Great. Okay. That was how you deal with bauxite. How do you deal with silver and gold? Well, these are very, very precious elements. Okay. So they don't usually form compounds with anything. But so you need to do something special to do the same thing. Idea is the same. क्या कर रहा हूं मैं यहाँ पे? मेरे पास कुछ solid चीजें हैं, उसमें से मैं चाहूंगा कि जो metal है उसको dissolve कर दिया जाए using some sort of a leaching agent, some solvent. Now in this case the solvent is going to be a cyanide ion. NaCN या फिर KCN को use करके in the presence of oxygen we get this. Now this may look like a slightly scary equation. Cyanide, yes, absolutely. Hey Deepanvita, awesome, that's great. Mayuk, man, you're on fire, Mayuk. Absolutely. ये इक्वेशन थोड़ी सी बड़ी है, अब क्या करें यार, एनसीईआरटी में दी है, अब क्या करें, पढ़ना पड़ेगा. ठीक है. द मेन थिंग आई वांट यू टू सी हियर इज दिस आयन. दोनों सिल्वर और गोल्ड कैन फॉर्म दिस सॉर्ट ऑफ अ थिंग, बट दिस इज इंटरेस्टिंग बिकॉज फॉर Ag+ दिस मेक सेंस. अभी देखो, आपने कोऑर्डिनेशन केमिस्ट्री पढ़ी तो नहीं है, आई नो फ्रॉम मी, बट आई एम श्योर यू ऑलरेडी हैव एन आइडिया अबाउट इट. अगर मेटल अंदर है और उसके बाद CN 2 बार है और पूरा चार्ज नेगेटिव है, यानी कि M का ऑक्सीडेशन स्टेट होगा +1, क्योंकि साइनाइड का है -1 इंटू 2, राइट? सो -2 +1 मतलब कि माइनस यहाँ पे हो गया, मतलब कि सिल्वर तो +1 में, गोल्ड भी +1 में हो सकता है क्या? सम फूड फॉर थॉट, थिंक अबाउट इट, ठीक है? एनीवे, मोर ऑफ दिस इन कोऑर्डिनेशन केमिस्ट्री। ये जो मैंने नंबर्स लिखे थे, ये आपको रेडॉक्स रिएक्शन कैसे बैलेंस करते हैं उससे यू कैन डू ऑल ऑफ दिस, ठीक है? दिस 8 कहां से आया, 4 कैसे आया, दिस इज अ सिंपल बैलेंसिंग आइडिया। ऑल राइट, ग्रेट। उसके बाद आई reacted with zinc, and this is also a very special reaction. Remember I told you just before this ki aluminium and zinc, they both form, you know, interesting compounds. Zinc forms this complex ion over here. This is not your regular redox reaction. I know आप लोग बोलते हैं ना कि अरे क्या था, maybe metal 1 and metal 2, metal 1 is this way, metal 2 is this way, and then you get M12 plus and M2. It looks like that, but it's not that straight because ये complex है और ये भी complex है. So this is very funky because zinc goes into that complex, breaks it apart and gets in there. So that's pretty interesting reaction. From the point of view of chemistry, like ये interesting नहीं है, मुझे मग करना पड़ेगा नीट के लिए. I get it, ठीक है. But ठीक है, the idea is the same. Okay, पहले मैंने dissolve किया and then after I dissolve it, I am getting something out of it. I am making the thing that I want soluble. यानी कि सिल्वर का जो आयन बनता है, Ag और Cn के साथ जो कॉम्प्लेक्स बनता है, that's the equation right on top. Hold on, let me just pause this so you can see the equation. You see this equation on top right here? Yeah, सबसे ऊपर लाल कलर में. Yeah, you can looks like displacement reaction, but I wouldn't call it that in the strictest of senses because as I said, ये complex एक metal दूसरे को कर रहा है. It looks like a redox reaction. I would like to agree with that. Yeah, it looks like that, sure. But there's more to the story because there's a complexes being formed. ठीक है? And मेरे सर के ऊपर जो reaction है, that was the first reaction I told you about. ठीक है? Sodium argento cyanide. जो आप coordination chemistry करेंगे, you'll learn how to name these compounds as well. Name these ions, these complex ions. ठीक है? After this, you've got this in solution. And मैं थोड़ा zinc powder डालता हूँ. जैसे ही मैं zinc powder डालता हूँ, what happens is pure silver precipitates out और solution में रह जाता है zinc का complex. That's the process. It's as simple as that. Cool? Are we good here? सब ठीक? Everyone is great? That's it. In the first 15 minutes, we have finished an important part of this, concentration of ore वाला business. Now, the next step is कि ठीक है, I've got concentrated ore. Okay, I've got multiple steps. या तो physical या तो chemical method से किसी ना किसी तरह मेरे पास concentrated ore आ गया है. अब उसको क्या करें? देखिए, what we do is we try and convert these concentrated ores into oxides. Okay, why into oxides? Because oxides are easier to deal with thermodynamically speaking. और एक सवाल मैंने आपको नीट वाले से जो पिछले नीट पे आया था लास्ट टाइम पूछा था कि why not nitrates? because nitrates dissolve हो जाते हैं, oxides generally नहीं होते हैं. ठीक है? Thanks, Deepanvita. I will let the team know. That's awesome. That's great to know that you like the animation. There are many more funky ones to come. Yeah, ठीक है. So I get oxides. ठीक है? This particular form is basically an oxide. और उसके बाद मैं उसको reduce करता हूँ. मैं कि यार क्या कर रहे हो लाइफ में? पहले तुम oxide बनाओ, then you reduce it. It may seem like a lot of running around circles, but this was the smartest way to do it, to save money and to do things at an industrial scale. इसलिए ये सब कर रहे हैं. ठीक है? Okay. So what is the first step? Conversion of ore to oxide. Next step is reduction of oxide to metal. The next step is what Ellingham diagrams are about. Right now we're going to look at the first step. So there are broadly two types of ores that I can look at. One type of ore that has oxygen atoms in them. Okay. The other is the one that doesn't. So सल्फाइड ओर हो या फिर कार्बोनेट या फिर हाइड्रेटेड ओर हो, इन तीनों को हम लोग ऑक्साइड ओर में कन्वर्ट करेंगे दो अलग अलग तरीके से. पहला तरीका होगा जिसमें what we call calcination. This is something that has oxygen in it. Okay. And roasting is usually for sulfide ores. मतलब अगर ऑक्सीजन नहीं है, रोस्टिंग यानी कि पीनट्स को जो फ्राई करते हो वो बहुत अच्छी तरह से आप उसको जस्ट देयर इज नो तेल बट हवा में आप फ्राई करते हो, राइट? तेल होता है क्या रोस्टिंग में? नहीं, तेल नहीं होता है. खाने वाले में तो तेल नहीं होता है. पीनट्स को रोस्ट मतलब कि बस ओवर फ्लेम, राइट? लॉट ऑफ एयर. कैल्सिनेशन, नो एयर. That's it. That's the main concept. Hey Raghav, I'm not sure who Ramlal is, but right back at you. Okay, so this is used for carbonate ores, and the interesting thing is कि मैं उसको इतनी ज़्यादा गर्मी देता हूँ कि the ore literally breaks apart. That's what calcination is. This symbol is heat. Okay? In the absence or limited supply of air. ये बहुत ज़रूरी है. Because उसमें already oxygen है, I don't want to give it oxygen any other way. If I do, it may mess things up. And plus, it increases my cost, so I don't need to do that. Okay? So all I do is I heat this ore that has carbonate in it at a very, very high temperature, and it literally breaks apart. Calamine and dolomite, these are examples of zinc and calcium ores. And you can also say magnesium ores in a way, because you both of these. ठीक है? Any doubt so far? Along with this, in calcination, carbon dioxide is given off. So 2 points in calcination. Point number 1, कि इसमें होते हैं usually carbonate ores. 2, CO2 is given off. And we'll say 3, you need to heat in the absence of air or O2. Cool? We good? That was calcination. Okay? Now, अगर hydrated ore है मेरे पास, I told you 3 types, right? One was carbonate, sulfide, and hydrated. Same idea. Heated, you get rid of this. We did that for the alumina wali cheese, right? We got from bauxite, we got alumina by passing it through NaOH, CO2, all that, and maybe heated it. Calcination, same thing. Absence of air, furnace में. वही same animation फिर से play कर रहा है. Okay? I'm gonna quickly skip it because we just saw it already. ये तो हमने भी detail में देखा था. आपको देखना है तो just rewind it and फिर से देख लीजिए. All right, sweet. So all of these impurities like sulfur, arsenic and Sb. What is Sb? Antimony. Antimony. As is arsenic. ये वाला तो simple है arsenic. S is sulfur. ठीक है. You get elements directly that go out. And the interesting thing is, because theoretically gas निकल रही है from this and what is left behind is solid, it's kind of porous. Okay? So its density is usually lower than that of the ore that you started off with. Does that make sense? Yeah? The solid is almost like it was before, but it's just that it's porous. Okay? Hey Maurya, that's awesome. From Aakash, that's great. We are Aakash too. Aakash BYJU'S right here. I know ये थोड़ा theory भारी हो रहा है, and I'm trying to make it a little bit interesting for you with all these funky animations. But anyway, roasting, generally used for sulfide ores. Sulfide ores कौन से होते हैं? Copper की और lead की और silver की. You remember from the last session? मैं आपको ऐसे PYQ इसलिए दे रहा हूँ ताकि आपको ये सीखने में भी आसानी हो. If you remember what we did in the last session, ये वाला session आसान होगा. All of them are linked. ठीक है? तो मैंने आपको 3 different बताया ना. Silver, lead और तीसरा कौन था? कोई है बताएगा? AGS या AGS. Perfect. AG2S होगा शायद, but good. We're good. We're alright. AG2S, that's alright. Silver, lead और copper. Right. इधर lot of air. ठीक है? Lot of air. Roasting, chana, peanuts, whatever. Here you use something called a reverberatory furnace, and this is also done at high temperature. ये जरूरी point है. Below the melting point of the metal. I don't want to do that as yet. Okay? Below the melting point of the metal. That's important. Okay? That's it. It's as simple as that. Here are some reactions. Okay? Zinc, lead, and copper are shown over here. And interestingly, in all of them, SO2 comes out. So calcination में निकला CO2, इसमें निकला SO2. और ये SO2, before I tell you what it does, here, let's check out a funky animation one more time. There you go. This is playing. So यहाँ पे हवा from this side, and then you've got zinc sulfide at the bottom, and as soon as it starts heating up, you get SO2 on top. That red stuff is supposed to show you that how hot it is, and yeah, absolutely, copper. Yes, Mayuk. That's it. That's it. Now, what happens here is this SO2 का क्या use हो सकता है? The thing in the industry is that you want to reuse things as much as possible, जो भी उसमें निकल रहा है, right? So this SO2 helps in the contact process. Contact process क्या होता है? Production of H2SO4. That's where SO2 is used. Hey, ये थोड़ा इधर हो गया. Wait, hold on. Yeah, that's me thinking. Okay, SO2 used for contact process. Okay, cool, great. Let's move on. कोई doubts है यहाँ पे? What happens if ores have impurities like Fe, iron? The thing is, and remember this, okay? ये चीज remember करो for the next session. We add silica, यानी कि sand. You're like, hey, hold on, sand sounds like an impurity. Yes, but here's the thing. Iron reacts with silica to give this iron oxide specifically, and this is slag, which just comes off as a slurry. And what's left behind is Cu2S and FeS. You be like, hold on. मेरा goal था to get oxides, but मुझे oxides मिले नहीं. It's all right. दिस इज वन ऑफ दोस केसेस जहां पे आयरन भी है, तो बिफोर आई डू दिस सल्फाइड वाला प्रोसेस दिस इज रोस्टिंग, आई विल डू दिस. ऊपर देखिए मैंने क्लियरली लिखा है, बट आई एम कॉलिंग इट आउट अगेन. बिफोर हीटिंग वी मिक्स इट विद सिलिका, ठीक है, ताकि स्लैग बन जाए और मैं इसको निकाल लूं, सो आई कैन टेक दिस आउट एंड देन आई डू दिस हीटिंग बिट. ओके, वी गुड? ऑल राइट, लेट्स मूव ऑन. क्विक एग्जांपल ऑफ दिस. समटाइम्स ये भी होता है कि if I have something that shows multiple variable oxidation states, then agar if I heat it in the presence of oxygen, it usually increases to the next oxidation state. I think that's all that I can talk about roasting for now without giving you a brain freeze. काफी ज़्यादा हो गया. खैर, so as I told you, sulfur, arsenic, and organic matter, all of that goes away like as volatile oxides. And again, this is similar to what you might call it calcination. But the difference, let me point out a difference as well. In calcination, what was coming out was the pure, element. Because usme hawa thi nahi, there was no air. But in roasting, you have oxides. That's the difference. What's common is both in calcination and in roasting, what you get in the end is porous. Okay? And the hydrous ores become anhydrous through roasting, which is the same as calcination. Okay. Now the fun begins. Reduction of oxide to metal. How many of you already know about this? That's water. I'm grabbing a glass of water. Anybody? 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 If you use a reducing agent, okay, that's interesting. Palladium and hydrogen. That's interesting. Okay, sure. So what we are trying to do is, what you're saying would work for, general reduction. I understand that. But here we're trying to reduce metals. If you remember the electrochemical series from lower grades, from 9th grade and 10th standard, you remember कि सबसे ऊपर काफी reactive metals है, नीचे और कम reactive और बीच में कहीं पे hydrogen था. Now what I'm introducing is कि besides that, when you did electrochemistry, just right about now, मेरे आने से पहले on this channel, you guys did electrochemistry, right? उसमें you saw कि carbon भी बीच में कहीं पे था. So anything that's above carbon, anything that's below carbon can be reduced by carbon, not above carbon, obviously, below it. हम लोग इसी चीज को थोड़ा और refine करेंगे. Okay, this idea. So I have a metal oxide and I put carbon or carbon monoxide or some other metal, then I can reduce it. A reducing agent gets oxidized. You remember this from redox reactions? Yeah? So, anyway, this is the generic reaction. But how do you do this? Yeah? कैसे पता चलेगा कि कौन सा करेगा, नहीं करेगा? And one idea is through the electrochemical series, but realistically speaking, we are doing these reactions at thousands of degrees Celsius. Who knows, temperature बदलने से कुछ बदल जाए. Yeah? Maybe what you expect does not happen at room temperature, does not happen at this temperature. What you're saying, palladium and hydrogen, all of that, could work for, say, double bonds. Yeah, adding hydrogen to that and all of, maybe it could work there. But यहाँ पे metal को reduce करने के लिए, we'll have to think of something else to do. Okay, anyway, we will have to heat it. Okay, that's for sure. So, what element would be a good reducing agent for a particular metal oxide? How do you figure that out? Thermodynamic principles of metallurgy, which is what is Ellingham diagram. Okay, so quick bit of a recall from thermodynamics. Delta G is delta H minus T delta S. ये याद आ रहा है? This is enthalpy change, this is the temperature, this is entropy change. This is going to be a deciding factor of everything we do. ठीक है? Because interestingly, as temperature changes, ये और ये ज़्यादा नहीं बदलते हैं. ठीक है? बहुत अजीब बात है. बहुत अजीब बात है. But entropy, I'm sorry, what am I saying? ये और ये ज्यादा नहीं बदलते हैं. टेम्परेचर बदलता है, डेल्टा एस और डेल्टा एस नॉर्मली कांस्टेंट रहते हैं, बट द वैल्यू ऑफ डेल्टा एस कुड चेंज इफ देयर इज अ चेंज इन स्टेट. यू रिमेंबर दिस फ्रॉम थर्मोडायनेमिक्स? मुझे लग रहा है मैं कहानी बोल तो रहा हूं, बट आप लोग थोड़ा सो गए हैं. उठ जाइए. दिस इज अ गुड टाइम फॉर यू टू गिव मी सम फीडबैक. रिमेंबर एट इक्विलिब्रियम वी सेड दैट कि माइनस एन आर टी एल एन के का आइडिया आता है. या when delta G equal to 0, then I can say that delta G naught equal to minus RT ln K at room temperature. G naught is that. मैंने not इसलिए हटा दिया क्योंकि I want to talk about any random temperature. ठीक है? and this K should be capital K. My bad. छोटा K होता है kinetics वाला, right? Rate constant. I'm not talking about that. I'm talking about capital K, which is equilibrium constant, which is right here. Okay, cool. So, in what conditions can this whole delta G thing be negative? If delta G is negative, मतलब process है spontaneous, मतलब अपने आप होने को तैयार है. अगर process spontaneous नहीं है, तो life becomes difficult. You remember this from electrochemistry? Do you guys remember this from electrochemistry? Yeah? कि अगर a chemical reaction happens by itself and produces electricity, great, that's spontaneous. But if it does not do that, you pass electricity and you make that reaction happen. Yeah? You make a non-spontaneous process spontaneous by passing electricity through it. That's not what we're talking about. We want to deal with spontaneous processes. मतलब हम चाहते हैं कि maybe we play with the temperature or do something else ताकि process खुद ही spontaneous हो. कौन सा process? We're talking about reduction of metal using carbon monoxide or some other metal. ये तीन चीजें. More temperature and entropy. Yes, Deepanvita Mayuk. Awesome. Great. So, I know ये topic थोड़ा सा heavy हो रहा है because you're like यार डॉक्टर ही बन करने के लिए मुझे ये सब क्यों पढ़ना पड़ रहा है? Life is hard, guys. I empathize with you. Yeah? Let's get through it together. Okay. But ये part interesting है. ठीक है? So, अगर delta G negative है, तो मतलब कि K is largely positive. अगर K positive है, K क्या है? Products by reactants. मोटे तौर पे, I know there is this thing to the power of A and B and C and D and all of that. वो सब चीजें हैं, I know. Stoichiometric coefficients, but largely speaking, it's some ratio of products and reactants. तो अगर ये largely positive है, मतलब कि products बहुत ज़्यादा है, मतलब reaction forward direction में जा रहा है. Okay, great, awesome, सही है. So, you know this is good, this is not good, this is equilibrium. So, delta G negative is what we want to do. Keep that in mind, that's the main thing. So, this diagram right here, called the Ellingham diagram, helps you figure out, okay, what is the best reducing agent at this temperature for this metal for me to reduce? Three things. Best reducing agent at this temperature, whatever that temperature may be, and for this metal. तीन चीजें कैसे आएंगी ग्राफ पे? देखिए, I'll show you very quickly. So what we do is we plot the change of delta G with temperature. Good to know, Lakshya. We plot delta G versus T, okay? And now here you have this main reaction over here. For this reaction you plot the delta G, यानी कि metal plus oxygen giving me metal oxide. इस reaction की delta G मैं plot कर रहा हूँ for many different metals. Now, how will this look like? If I plot, say, delta G versus T, okay? Say delta G की कुछ value है. Now, in this case, since there was a gas initially and finally gas नहीं है, तो मतलब delta S is negative. अगर delta S negative हुआ, तो delta G equal to delta H minus T delta S. तो अगर delta S negative हो गया, तो ये वाला positive हो जाएगा, है ना? है ना? So if that becomes positive, यानी कि अगर delta G कुछ यहाँ पे 0 है, तो this is negative say 1000. So अगर यहाँ पे है, तो ये इसकी value बढ़ती जाएगी, ऊपर जाएगी. Is this part clear? Please ask me doubts if you have them right now. In such a reaction, where a metal which is a solid reacts with oxygen which is a gas, gives you another solid, delta Ng, number of gaseous moles is -1. यानी कि entropy जो है कम होगी. क्यों? क्योंकि जब gas है which is more disordered form becomes solid which is less disordered, then entropy तो कम हो गई. अगर entropy negative हो गई, मतलब कि T delta S वाला term positive हो गया. अगर T delta S वाला term positive हो गया, तो delta G अगर शुरुआत में negative थी, but उसका graph will be an upward slope. Is that okay? मैंने पूरी चीज फिर से repeat की है. Please give me like a sign that this is good and then we'll move forward. Okay? Because ये बहुत जरूरी है. Because otherwise the other diagram that comes up is going to be really scary, which is this one right here. Like, oh my God, what's happening here? You got so many of these lines going upward, right? And then there's this one chap here doing its own thing, like this line. Like, what on earth is that? Right? And then there's lines that are changing slope. यहाँ से यहाँ हो गया. I see 3 lines changing slope upwards. And I see one line just doing its own thing, like changing slope downwards. Okay, I'll talk about all of this. And यहाँ पे 0 है, this is negative this way. Okay, and this temperature, thousands of degrees Celsius, as you can see. Cool. So, ये तो मैंने explain कर दिया, right? The slope for the graph of XM and MOX is positive. And delta G increases with the increase in temperature. ठीक है? कूल इंक्रीज मतलब पॉजिटिव होता जाता है, इसलिए ये स्लोप ऊपर जा रहा है. बट ये पॉइंट्स क्यों है? let me talk about this slope suddenly increasing. In 3 cases I see the slope suddenly increase हो रहा है. ये क्यों हो रहा है? Let me first talk about that. So अगर जो हमने प्रोडक्ट बनाया, और नॉट प्रोडक्ट, let me call it, the thing that I started off with. I started off with the metal and I have oxygen and I get MO like X or whatever, right? अगर ये चीज मेल्ट या वेपराइज हो जाती है, then what happens? Then instead of this being solid, this becomes liquid. और ये लिक्विड हो गया तो एंट्रोपी जो ऑलरेडी नेगेटिव थी वो और भी ज्यादा नेगेटिव हो जाती है. 2 नेगेटिव साइन डाल दिया मैंने, मेक्स नो सेंस, आई नो. तो या दिस इज मेक सेंस because I had one solid and one gas becoming one solid, okay, but now I will have one liquid and one gas becoming solid. That means entropy change और भी ज्यादा हो गया, और भी ज्यादा नेगेटिव हो गया, इसलिए स्लोप और भी ऊपर चला जाता है. ठीक है, इसका एग्जाम्पल है Hg और HgO at 356 डिग्रीज. Hg बॉइल्स, लिक्विड मैंने एग्जाम्पल दिया, और वो लिक्विड वेपराइज भी हो सकता है, गैस भी हो सकता है. तो ये जो इफेक्ट है ऑफ suddenly something becoming a liquid or a gas, that has a very very big effect on entropy. Otherwise both entropy and this thing doesn't change too much with temperature, okay. Entropy and delta H values are almost the same until there is a change of state. In that case only entropy is affected. ये जरूरी बात है, ठीक है. Similarly magnesium boils at this, hence there were 2 of these slope changes, okay. ये तो मैं आपको बता ही चुका हूं. There is a large change in entropy associated with change in state, and hence you've got this, okay. Now interestingly there's a point in the curve of the graph जिसके ऊपर अपने आप ही ये डिकम्पोज हो जाता है, अपने आप डिकम्पोज. अच्छा, you remember that whole calcination वाली चीज, या फिर this thing where you heat it a lot and it breaks apart. तो ये भी हो सकता है. इसके नीचे डेल्टा जी नेगेटिव होगा, hence this is stable, okay. ठीक है, ठीक है, that's another point. So look at this right here, right? So ये जो ऊपर वाले स्लोप थे, ये जिंक है. जिंक मेटल जो है सीधे लिक्विड बन जाता है, सीधे गैस बन जाता है, ठीक है. Hence you got that thing going upwards. Magnesium also same thing happens at 1100 something ना. पीछे क्या था? Let me just go back and see the actual temperature. Hold on 1 second. हाँ, boiled at 1120 degrees Celsius, right? इसलिए वो यहाँ पे था. We are back over here, right? 1120 degrees Celsius. Cool. यहां पे मैंने एक पॉइंट ए को हाईलाइट किया है. व्हाई डू यू थिंक दैट इज? देयर आर 2 लाइंस. ये वाली लाइन बरकरार है, ऐसी जा रही है. ये वाली लाइन जाके थोड़ी ऊपर जा रही है. बिकॉज इट्स चेंजिंग इट्स स्लोप, दे इंटरसेक्ट. व्हाट डज दिस इंटरसेक्शन मीन? एट दिस पॉइंट इन दोनों रिएक्शन का डेल्टा जी 0 होगा. इन दोनों रिएक्शन का मतलब कौन सा रिएक्शन? अगर मैं इसको ऐसे ही रखूं, राइट, एंड इस रिएक्शन को उल्टा कर दूं, मतलब कि इंस्टेड ऑफ Mg गिविंग MgO, आई एम राइटिंग द ऑपोजिट रिएक्शन, 2MgO, है ना. तो लेट्स कॉल इट रिएक्शन 1, रिएक्शन 2. तो रिएक्शन 2 इज बीइंग रिवर्स्ड. सो रिएक्शन 1 माइनस रिएक्शन 2 विल बी माय डेल्टा G, बट दिस वैल्यू स्टिल नेगेटिव. इज इट? इज इट नेगेटिव? इज इट नॉट नेगेटिव? आओ, उल्टा हो गया यहां पे. देखो, ध्यान से देखो, रिएक्शन 2 एज इट इज रहेगा. अच्छा, हाँ, या नो रिडॉक्स रिएक्शन बिटवीन 2 मेटल्स. रिडॉक्स रिएक्शन की हम लोग कोशिश कर रहे हैं. द लोअर मेटल विच इज मैग्नीशियम, ओ या दिस मेक सेंस, मैग्नीशियम मोर रिएक्टिव देन एल्यूमिनियम, राइट. सो जो लोअर मेटल है वो एज इट इज रहेगा, Mg plus O2 gives MgO. बट जो ऊपर वाला मेटल है उसको हम लोग रिवर्स कर सकते हैं, यानी कि Al2O3 gives me एल्यूमिनियम प्लस ऑक्सीजन. ठीक है, मैंने बैलेंस नहीं किया है, मतलब कि आई एम रिवर्सिंग द फर्स्ट रिएक्शन एंड हेंस डेल्टा जी इज नेगेटिव, राइट. क्योंकि से डेल्टा, ये 2 का जो है अप्रोक्सीमेटली क्या वैल्यू थी? नेगेटिव 1100, राइट, एंड इसका था नेगेटिव 1000. तो दिस माइनस दिस इज स्टिल नेगेटिव 100, राइट, विच मीन्स कि ये रिएक्शन स्पॉन्टेनियस है. कौन सा रिएक्शन? इन दोनों का. मतलब कि मैग्नीशियम एल्यूमिना को रिड्यूस कर सकता है अबव, व्हाट इज दैट टेम्परेचर, क्या दिख रहा है यहाँ पे? इफ आई टेक इट डाउन, समथिंग लाइक 1500 डिग्री के आसपास, या सो अराउंड 1500 डिग्रीज मैग्नीशियम कैन रिड्यूस alumina. So any metal that is lower than the other metal on this Ellingham diagram can reduce. Is this okay? That's the main takeaway over here. ज़्यादा हो गया? Any doubts? Any doubts, guys? I'll revisit this if you want. I'm going to move on for now on. Okay? So, the whole goal is that you got to figure out किस temperature पे ये होता है. Right? Because the two need to cross, or if they don't cross or whatever. Basically, जो नीचे वाला metal है, वो ऊपर वाले को reduce कर सकता है. That's the main idea. But उल्टा भी हो सकता है. देखिए, above this temperature, the opposite can happen. Above this temperature, aluminium can, this is magnesium वाली line, ये aluminium वाली line है. मतलब aluminium metal can reduce MgO above this temperature, right? जो नीचे वाला है वो ऊपर को reduce कर सकता है. 2200K, अभिनंदन, amazing bro. That was great. That was great. Okay, so that's the whole point of this Ellingham diagram. Any doubts, guys? I know ये थोड़ा भारी है, बहुत भारी है, थोड़ा नहीं बहुत भारी है. कोई डाउट है तो पूछ लो. How are you guys feeling? Everyone doing okay? So clearly, blast furnace. Yes, sure. We'll talk about that in the next session. Blast furnace. Yeah. Thanks, Dipanwita. So aluminium, जो बहुत नीचे था Ellingham diagram में, it was very low. It reduces everything above it, right? What was above it? Zinc, iron, titanium even. But it can't reduce MgO below 1500 degrees Celsius. As soon as you go above 1500 degrees Celsius, which is this guy, then aluminium can reduce magnesium, right? Because मैं इस reaction को उल्टा कर रहा हूँ. Let's say call them reaction 1, reaction 2. So reaction 1 minus reaction 2 is negative here in this region. Okay? Cool? That's it. So that was very interesting. Whew. But क्यों, how is this possible? मैं आपको डिटेल में समझा ही चुका हूँ, right? Delta G becomes more negative by a difference between these two graphs at that particular temperature. Okay? So you can look at it another way with an example. Yeah? So I will use carbon this time around as a reducing agent. Okay? Now, coke is a very, very popular reducing agent. We didn't see it. And where was carbon in all of this? Carbon तो दिखा ही नहीं. Carbon था. ये सब metal metal carbon कहाँ है? Care, we look at different things, right? So there are multiple ways in which carbon could be a reducing agent. Remember, my goal is to reverse this reaction. Okay? This is what we have. If I react this with carbon, I get mx, x times m, sorry, plus oxygen, which is this right here. Okay? So what I can do is, okay, carbon can be a reducing agent. Then it can form carbon monoxide. अगर मैंने हवा की quantity कम कर दी, then it forms carbon monoxide. If I use carbon monoxide itself as a reducing agent, then I can give it enough oxygen, become CO2. Or a third thing I can do is कि carbon को ही enough oxygen दे दो, the third oxidation agent, which is third oxidation type, which is कि carbon को काफी oxygen दे दो and directly it gives you CO2. ठीक है? So these are three different ways where we can use reducing agent, and this will be used in blast furnace as Abhinandan just pointed out there. So what I will do is कि ये जो expression है, इसको I subtract, मतलब इसको I reverse, right? When I reverse this, this becomes MXO, gives me XM plus half O2 or whatever that is. That basically happens when it reacts with either carbon or carbon monoxide or carbon. Hold on. In one way you get CO2 and one way you could get CO. ये सब reaction आपको देखने को मिलेंगे blast furnace में. I'm just mentally preparing you for that when it happens. Okay? All right. Awesome. So ये जो slope है, क्यों है ऐसा? Of carbon. Now where is carbon? This is very interesting. Look at this line. It's a straight line. It's a flat line. This is carbon plus oxygen give me CO2. और बाकी कहाँ गए? ढूंढते हैं. ये देखो, इस महाशय को देखिए. ये तो बिल्कुल उल्टा नीचे जा रहा है. It's like against the grain. It doesn't care. सिंपल स्क्रीन, ये को बढ़िया स्क्रीन नहीं दिख रही है, मजा नहीं आ रहा है तो एनसीईआरटी पढ़ लीजिए. एनसीईआरटी नहीं पढ़ सकते इसलिए तो हम कर रहे हैं ये सब. एनसीईआरटी में सब कुछ दिया ही हुआ है ना? खैर, सो यू गॉट दिस रिएक्शन गोइंग दिस वे. ओके, नाउ वेयर इज द थर्ड वन? तीसरा वाला कहीं दिख रहा है आपको इधर? Here you go. Look at this. This has a similar, sort of a thing, just like metals do. Okay? नहीं, ये वाला तो दूसरा है, ये वाला नहीं. Hold on. This is the carbon line. This ये तो zinc वाली line होगी. ये जो है, ये line है carbon monoxide और carbon dioxide वाली. Cool. So I have somehow in this very crowded diagram identified three things. Okay. कौन सा? Carbon plus oxygen giving me CO2, which is a flat line. Okay. And carbon plus oxygen giving me CO, which is a line sloping downwards. And a line sloping upwards, which is carbon monoxide plus oxygen giving CO2. Why does this happen? That's what we're going to explore now. Okay. So let's look at this. When you have carbon plus oxygen giving carbon monoxide, you balance that reaction. You see that the total number of moles right now of gases is what? 2 minus 1, which is equal to 1. यानी कि delta S is positive. अगर delta S positive है, तो delta H minus T delta S. That's interesting. मतलब अच्छा, this is just like that. नहीं, ये उल्टा हो, ये वाला नीचे जाएगा. Is that correct? This one will go down. Is that correct, or what do you think? What do you guys think? Is this going to go down? Is it going to go up? Is it going to be flat line? Which of the three is this? I'm talking about carbon reacting with oxygen to give me carbon monoxide. Okay. So from our reduction, we've got that, okay, carbon monoxide में 2 moles थे गैस के, यहाँ पे 1 mole है गैस का. That means कि delta S must be positive. Okay. And we don't reach a point जहाँ पे carbon melt होके gas बन जाता है. That happened like, I don't know, like 4000 degrees Celsius or something. It's at a very, very high melting point and all that. So इसलिए this doesn't matter. So I think maybe it should go downwards. Is that what happens? Let's check. Let's check. देखो यही हुआ यहाँ पे. This is exactly what we deduced, right? Are you convinced with this? Please give me a thumbs up if this is okay. Yeah? कि ये downward slope क्यों था इसका? क्योंकि the number of moles of gases is more when the products are formed as compared to the reactants. मतलब delta S was positive. So, delta S positive हो गया, मतलब कम हो जाएगा. ठीक है? Cool. What about CO? What about CO? Hold on. I'm going to go to that one right now. So, when I take carbon monoxide, which is a gas, यहाँ पे तो बहुत clear है कि ये entropy कम हो रही है, right? I've got 2 moles of gases, 1 mole of gas and 2. So, delta Ng here is negative, which means delta S is negative, which means कि ये positive value होगी, right? T delta S is going to be positive. Negative T delta S is going to be positive. Delta H minus T delta S. Okay. So, इसकी slope ऊपर होनी चाहिए. This way. Let's quickly see that. Is that what happens? जहाँ पे हम लोग को मिल रहा है. Remember, your product right now is CO2. Product अगर CO2 है, कहाँ गया? हाँ. देखो. Yes? You with me? I know ये भारी चीज़ है भाई. This is 2 which we have proved. 1 which was proved. And तीसरा वाला सबसे आसान वाला मैंने एंड में रखा. CO2 सिंपल है. देखो CO2 में कार्बन था और ऑक्सीजन है और यहाँ पे CO2 बन रहा है. In this case, you got 1 mole of this, 1 mole of this. Since the number of moles of gases doesn't change, ये flat line होगी. Okay? This is why this is a flat line. इससे ज़्यादा आपको इंटरनेट पे कोई नहीं पढ़ाएगा. ठीक है? You go to any advanced thing, कोई whatever you see. And once you remember this, you'll never forget it. So this is why you have the different ways of carbon monoxide and carbon dioxide on this graph. Okay. That was interesting, huh? ठीक है, cool. We just went through this. I know काफी detail में हो गया. What's the conclusion? What's the conclusion? You choose a temperature such that delta G is negative and of the whole reaction, which is one reaction and the other one is reversed. Which one is reversed? जो ऊपर वाला reaction है उसको हम लोग reverse करते हैं, नीचे वाला as it is रखते हैं, ताकि when you subtract, even after that delta G total is negative. एक important idea जो NCERT में लिखा था. Hey Poonam, awesome, that's great. NCERT में एक बहुत interesting चीज लिखी थी, right? That this is only telling you that whether a reaction will happen or not theoretically. Delta G के हिसाब से बता रहा है. अभी actually हो या ना हो, वो तो खुदा के हाथ में है. Kinetics, right? So if kinetics demands it, then it happens. Like for example, ये last वाले session हम लोग करेंगे thermodynamics के. You check that out if you want on the 11th grade. the conversion of graphite to diamond is a spontaneous process. But होता थोड़ी ना, नहीं तो फिर हम लोग भी और भी अमीर ना, ग्राफाइट उठा के लाओ डायमंड बन जाए, because of kinetics. उसका kinetics इतना slow है कि होता ही नहीं है. So Ellingham diagram just talks about the energy. Actually है कि नहीं, होता है कि नहीं, that depends on kinetics, which you can speed up by increasing temperature and all of that. That's what that second part of NCERT says. Please दोस्तों NCERT पढ़ लीजिए लाइफ में. Your life will be good if you do. And in this thing, at the intersection of two curves, you can figure out कि अच्छा इस temperature के बाद चीजें बदल सकती हैं, like we did in terms of magnesium and aluminum, if there is an intersection. All right, awesome. Here you go, right? That's what I'm just saying over here. ये मैं बहुत detail में बोल चुका, I'm not going to bug you with it. Next point is that, yeah, ऊपर वाला जो है reaction is what is reduced, which means कि that one you turn around, right? MO to M. And this guy you keep as is. तो इसको मैं reverse किया, this gets reduced by an element present in the lower line. ये भी बता चुका हूँ, blah blah blah. All right, and the bigger the difference, the better it is, the more feasible it is. Easier the reduction. Easier मतलब कि energy wise easier. Now when I'm saying easier and harder, remember this just has to do with delta G values. In real life, as I told you, kinetics is a big factor, and if this energy is released too quickly, that's a bomb, right? Like any energy being released very quickly is not good. Or if it doesn't happen at all, then that's not good either. So you take things with a pinch of salt. इसीलिए in real processes, you will see कि हम लोग 10 और चीज करते हैं. We will take a lot more headache. Like for example, in the next couple of sessions, please NCERT बढ़ के आएगा. When you figure out the extraction of alumina, उसमें हम डालते हैं फ्लोर स्पार, क्रायोलाइट और 10 चीजें डालते हैं और कार्बन ये करते हैं, बहुत हॉल हेरोल प्रोसेस, बहुत they split hairs to figure this out. But why? उसमें और होती है कुछ 12% या 13%, ठीक है? So the deal is that real life is a lot more complicated than what you study in a book, but you got to study what's in the book to understand that, ठीक है? We've ended today's session a little quick. Hey Siddhant, CAF2, yes, floor spar, good job. We've ended today's session a little quickly because I thought कि यार ज़्यादा हो जाएगा. Ellingham diagram is a lot. In the next session, I'm going to talk about what the application of Ellingham diagram are. Here is a homework question for you. First one, AIPMT 2007 से. Or here is another one. Metal oxide cannot be reduced by metal carbon is. Last session I didn't really give you any homework question क्योंकि introduction था, didn't have too much to do. Khair, a quick summary of everything we've done so far. Yeah, we started this with the whole idea of leaching. Leaching में हमने दो type की leaching की, right? First one was alumina की leaching. पहले हमने उसको dissolve किया NaOH में, we got a complex, and then we said कि hey, you know what? Let's neutralize this with carbon dioxide. Once we did that, we got a high-grade ore, then we calcinated that ore. Okay, जब हमने उसको calcinate किया, तब हमको मिला nice and dry Al2O3 that we will use in the fourth session how to get this. Yeah, pure alumina. खैर, और अगर गोल्ड या सिल्वर है, then उसको हमने बोला कि चलो पहले हम लोग करेंगे, इसका एक स्टेप स्किप हो गया, रुको, कहाँ गया? हाँ, पहला स्टेप यहाँ पे है नहीं, but you can find it in this thing. You first step is that you react it with NaCN or KCN. What do you react? You react the Ag or Au, and it has some impurities, right? So the impurities they go away, and then you do this, and this goes into solution, and this is a precipitate, which is your nice pure metal. Isolation of metal में क्या क्या steps है? पहले तो you convert to oxide and then you reduce. इसमें हमने क्या किया? Calcination and roasting. Calcination में हमने बोला कि देखिए, this has to be done for things where you have carbon dioxide comes out where you have carbonate ores, right? And you get porous things at the end. And roasting में we said, like peanuts, right? You have sulfide ores and then you heat them to get, well, sulfur dioxide comes out and you get oxides at the end. फिर से porous होता है and what you get are volatile oxides. Last time you got volatile elements. One more small thing, अगर आपके पास इसमें FeO भी होता है, then that FeO के साथ you add acid O2 पहले, that becomes slag, and after that you do all of this. Thanks Laksha, thanks a lot. पूनम B, अच्छा तुम होमवर्क सवाल दे रही हो जवाब? अरे यार होमवर्क सवाल का जवाब यार कमेंट्स में दो प्लीज, या? And if you like it, hey, hydrometallurgy, that's very awesome. Lakshya Siddhant, if you guys like the video, I know you all have subscribed to it. Tell your friends about it. Maybe ask them to subscribe, check it out and all of that. All right, thanks for the encouragement. Love you guys. All right, Ellingham diagram, complicated, but I think not. After what we have done, कभी नहीं भूलोगे यार लाइफ में. और भूल भी गए तो फिर से वीडियो है देख लेना, क्या फर्क पड़ता है, 5-10 मिनट जाएगा लाइफ में and you'll be set. ठीक है? Won't bug you. ये तो बहुत डिटेल में गया हूँ. Stuff is on your screen right now. Yeah, we figure out a temperature so that which is the best for that sort of reduction. मतलब कि दो रिएक्शन है, नीचे वाला रिएक्शन ऊपर को रिड्यूस करता है, यानी कि ऊपर वाले रिएक्शन को मैं कर सकता हूं, बदल सकता हूं, आई कैन जस्ट टर्न इट अराउंड. ठीक है, ऑसम. एंड अगर देयर इज अ पॉइंट ऑफ इंटरसेक्शन, आफ्टर द पॉइंट ऑफ इंटरसेक्शन थिंग्स चेंज. ये भी हमने देखा था इन टर्म्स ऑफ मैग्नीशियम एंड एल्यूमिनियम. All right, and we saw that कार्बन डाइऑक्साइड जब बनता है तो फ्लैट लाइन थी, एंड देन देयर वाज अ डाउनवर्ड लाइन, अपवर्ड लाइन. बहुत डिटेल में ऑलरेडी एक्सप्लेन किया है. So that's it from me for now. I hope you guys had fun. And hey Anant, what's up? Yeah, काफी intense. Didn't have too many questions for you in this session. थोड़ा theory heavy था. सवाल होंगे अगले सेशन में. And what we are going to do next is thermodynamics. When are we going to do thermodynamics? हम लोग करते हैं, आज तो फ्राइडे है ना, तो on Monday I'm thinking I'll do 2 sessions. Great Mayuk, good to know. हाँ यार सिद्धांत, थोड़ी सी तो जरूरत पड़ेगी. If you would want, try and watch my session on thermodynamics itself. That's going to come up. अभी किया नहीं है, in this week it'll come up. Or you can check out this. अगर ये समझ में आता है great, अगर नहीं आता then wait for my 5th session on thermodynamics. 5th या 6th session I think. We'll do that. On Monday I'm going to do 2 sessions. At 4 o'clock I'm going to do इसका 3rd session, and at 7 o'clock I'm going to do 4:30 I think, 4:30, and 7 o'clock I'm going to continue thermodynamics. I'll see you around. पूनम, सवाल होंगे अगले सेशन में. Stay tuned for the next episode of Metallurgy. All right, bye bye. See you all.